This is Bob Capetta, and this lesson is on surveys and Venn diagrams. So we're going to start with the Venn diagram, two sets, A and B, sitting inside the universal set. So these two regions make up set A, these two regions make up set B, these four regions make up the universal set. So I ask, what are the number of elements in set A? Well, there's 12 in this region, 7 in that region, for a total of 19 are in set A. How about set B? B consists of these two regions, 15 and 7, which would give us 22. A intersect B, that means where do they overlap? Which section is common to both A and B? These 7 items are in the overlap, so the number of items in A intersect B is 7. How about A union B? That means you're either in set A or in set B or both. 12, 7, and 15 are either in A or B or both. So 12 plus 7 is 19, plus 15 is 34. The number of items that are not in A, well, A consists of these 12 and these 7. So that's 15 plus 9, or 24, are not in A complement. Remember, A with an accent mark is complement. Number of B complement, not in B. 12 not in B here, 9 not in B there, for a total of 21. How about in A and not in B? In A and not in B. So what's in A? These two, but not in B just put you here. So in A and not in B just is going to give us 12. Not in A but in B. So in B, these two not in A just focuses us here at 15. Not in A and not in B, that's outer space, that's just the 9. I didn't ask you for the number in the universal set, but I certainly could. 12 and 7 is 19, and 15 is 34, and 9 more is 43. That's the number of items in U. Okay, this time I'm going to actually give you the numbers for A, B, A union B, and U, and our goal is to construct a Venn diagram. But to do that, I need to find A intersect B, and here is our rule that we need to remember. The number of items in A union B, add up the number of items in A plus the number of items in B minus the overlap, because the overlap's been counted twice. So number in A plus number in B minus the number of A intersect B. So number in A union B is 50 equals number in A 25 plus number in B 32 minus the number in both A and B, A intersect B. So 25 and 32 is 57, so we get 50 is 57 minus the number of A intersect B. So I hope it's obvious. If that's the case, then the number of A intersect B has to be 7. So knowing that, that enables me to start filling in the numbers in my Venn diagram. So we have set A, set B. Here's our universal set, of course. A intersect B is 7. 7 is going to go in the middle. Now the total of A is 25, so these two regions have to add up to 25. That's 7. What does this have to be to give me 25? It's got to be 18. These two regions add up to B. B is 32. 7 plus something is 32. 7 plus 25 is 32. So 18 and 7 is 25, and 25 more is 50. So I've used up 50 in these three regions. My universal set has 63, so we must have 13 more in outer space. So we've successfully constructed our Venn diagram. Now we can answer some questions about that Venn diagram. For example, what are the number of items that are in A and B complement? In A but not in B. In A and not in B. In A, these two. Not in B, just puts it here. That's 18. How about in B and not in A, or not in A and in B? So in B and not in A puts me right here, just gives me 25. Not in A and not in B? What's both not in A and not in B? The only thing is outer space, which is 13. So you can see the process. Given 4 bits of information, we were able to create the Venn diagram for this universal set U. And from that, we can answer many questions about the number of items in those various sets. So we're going to graduate to a word problem this time. And I'll say there are 120 students in a mathematics lecture at a university. 50 of those students attended a college football game in the last year. 30 of those students attended a Major League Baseball game in the last year. 6 students attended a college football game and a Major League Baseball game. Construct a relevant Venn diagram. Now remember, a set must be well defined, so here's how we're defining it. 120 students sitting in a lecture hall. The professor asks, how many have attended a college football game in the last year? 50 raised their hands. Then he asks, how many had attended a Major League Baseball game in the last year? 30 had raised their hands. Now, that does not mean the 50 people only attended a college football game and no other sporting events. Because the professor then asks how many attended both a college football game and a Major League Baseball game, and 6 raised their hand. So that's how we're choosing to define this. So if that's the case, we start with our universal set. 120 students in the mathematics lecture, that's what we're starting with. 50 of those attended a college football game, so I like to use a letter that reflects that. So I'm going to use the letter F for football. The number of people who attended the football game is 50, and the number of those who attended the baseball game was 30. But now 6 attended both, so that's football and baseball. So in both football and baseball is intersection. The number of people who attended both the football game and the baseball game is 6. So we're going to construct a relevant Venn diagram and then answer some questions about this group of 120 students. So here's my universal set. We have the set F, which consists of these 2 regions. The set B consists of these 2 regions. We always start with the intersection. I'm going to start with F intersect B is 6, so 6 goes in the overlap. Football adds up to 50. If I have 6 here, how many more do I need here to get to 50? 6 plus 44 is 50. Baseball adds up to 30. If I have 6 here, how many more do I need to get to 30? 6 plus 24 is 30. So what have we used total? 44 and 6 is 50, plus 24 is 74. I need to get to 120. What else is in outer space? What is in the universal set but not in these 3 regions? 120 minus 76 is 120 minus 74 is 46. So we have constructed our relevant Venn diagram. Now we're going to answer some questions about these various sets. So here's the Venn diagram. How many students attended either a college football game or a Major League Baseball game in the last year? Well, either football or baseball. That's union. So what is the union going to be? 44 plus 6 plus 24 in the first set or the second set or both. Do not count the 6 twice. 44 plus 6 is 50 plus 24 is 74. So we have a total of 74 people that attended either a college football game or a Major League Baseball game. In set theory notation, that would be F union B. How many students attended a college football game but did not attend a Major League Baseball game in the last year? So they attended football but did not attend baseball. So how do we define that in terms of set notation? Football and baseball complement. Football and not baseball. So if we look at our diagram, football is here, not baseball moves me out of the overlap and just into the 44. So football and not baseball gives us a total of 44 people in that group. Our next question says, how many students did not attend a college football game and did not attend a Major League Baseball game? They did not attend a football game. They did not attend a baseball game. Who did not attend? Where does that put me? So not football and not baseball puts me in outer space, puts me in 46. So again, that's a word problem. Given all these details, we're able to convert those details We're able to convert those details into various mathematical terms that we use to construct that Venn diagram, right? Here they were. Number of universal set, number of football, number of baseball, number of football and baseball. Once we constructed that Venn diagram, then we were able to answer those various questions that we gave. Questions like this one. So let's jump to another word problem here. A researcher surveyed 77 political science students about television networks that the students watch at least once a week. And here's the results. 30 students watch CNN at least once a week. 40 watch ESPN, 27 watch PBS. 17 watch both CNN and ESPN. 14 watch both CNN and PBS. 8 watch both ESPN and PBS. 3 watch CNN, ESPN, and PBS. Now realize this. When it says in math 30 students watch CNN, that does not mean CNN and nothing else. That's the complete collection of people who watch CNN. If you want to use the metaphor from the previous problem, there are 77 students in a lecture hall. The professor asks, how many watch ESPN at least once a week? 30 raise their hand. So it's not a multiple choice where you're picking one of these. You're just asking, is this true? Do you watch ESPN? 40 said yes. Do you watch PBS? 27 said yes. Do you watch CNN and ESPN? 12 said yes. So many people are counted multiple times. So we want to construct our relevant Venn diagram. Well, how are we going to do that? So 3 regions, C for CNN, E for ESPN, P for PBS, U for universal set. Always start with the one that is got 3 items, CNN and ESPN and PBS. Where does that put us? In the dead center of this Venn diagram. So there are 3 people in all 3 groups simultaneously. So I call that 3 Z's. Then you go to the ones 2 at a time. So where did we go next? CNN and ESPN. 12 people watch both CNN and ESPN. CNN and ESPN are these 2 regions. 3 has been used. It's got a total 12. How much more do I need in this spot to get it to add up to 12? I will need 9, of course. Next up, we are going to go to CNN and PBS. CNN and PBS is 14. Where are the regions? CNN and PBS right here. Have to add up to 14. We have 3 in this cell. How many more do I need to get it to add up to 14? 3 plus what is 14? Of course, 3 plus 11 is 14. And I have one last twofer. 8 watch ESPN and PBS. So where are those? 2 together. ESPN and PBS. 8. 3 here. How many more do I need to get to 8? 3 more. I will need 5. Need 5 more to get to 8. So those are all of my 2 at a time. So now I'm able to go ahead and look at the 1 at a time. So let's start here with 30 students watch CNN. CNN is these 4 regions. 11 plus 9 is 20, plus 3 is 23. How many more do I need to get to 30? The answer is 7. Let's look at ESPN next. 40 watch ESPN. 9 and 3 is 12, and 5 is 17. 17 to get to 40, how many more do I need? I need 23. And PBS, a total of 27 watch PBS. What do I have so far? 11 and 3 is 14, and 5 is 19. I have to get to 27. If I have 19, 27 minus 19 is what? Is 8. So you may feel like you're finished, that we have filled in all of the numbers in the regions in the circles, except we have neglected to put a number in outer space. There are a total of 77 students. So how do I figure what goes in outer space? What do I have to do? I've got to add all these up, right? 7 plus 9 plus 3 plus 11 plus 23 plus 5 plus 8. And that is 66. If I add 11 more, that'll get me to 77. So 77 is the number that I have total. 66 in these 3 circles and 11 in outer space. We have now finished up the relevant Venn diagram. Now from that Venn diagram, we are going to answer some questions. How many of these students watch at least one of these networks? Well, again, either CNN or ESPN or PBS. So our notation in set theory is C union E union P, which is 7 plus 9 plus 3 plus 11 plus 23 plus 5 plus 8, which gives me a total of 66. Again, that's our union. That is everything in the 3 circles. Now, recognizing that we have 77 total, we could have just taken 77 minus 11, right? To figure out what's in the 3 circles, if there's a total of 77 and 11 in outer space, there's got to be 66 in the 3 circles. Our next question, how many of these students watched only CNN? Only CNN, so CNN and not another network. Well, CNN consists of these 4 regions. Which one is only CNN? Just that. Now, how do we express only CNN using set notation? C and, or intersect, not E, and not P. C intersect E complement intersect P complement, which is just going to give us the 7 that we mentioned for that section, only watching CNN. How many of these students watched ESPN and PBS but not CNN? ESPN and PBS. Where's my overlap of ESPN and PBS? Here. ESPN and PBS overlapped here. But not CNN. Boom, it moves me out of the triple overlap and moves me just here to the 5. So how do I write that in set notation? E intersect P intersect C complement. ESPN and PBS and not C just gives us the 5 that we mentioned. Our next question is, how many of these students didn't watch any of these networks? So that's not CNN, not ESPN, not PBS. How do we write that? C complement intersect E complement intersect P complement. What is the total? That, of course, is outer space. That is just 11. And that will complete this lesson.